Good afternoon. We are Group 3 of Section 2 of Molecular Transform Phenomenon, and we are going to explain the report for practice number 1 on molecular dynamics. For our presentation, we are going to have 5 different sections starting with the introduction, followed by the methodology, then results, discussion of results, and finally conclusions. To start, we must be clear some concepts, among which we find molecular dynamics, which is a computational simulation method that allows us to analyze molecular interaction at the atomic level. This simulation allows us to analyze the change of a molecular system over time, known as a trajectory. For this, we will use GROMATS, which is a high-performance program used for the simulation of molecular dynamics of systems with hundreds of millions of particles. These programs allow us to simulate the Newton equation of motion, in addition to being one of the fastest and most used programs that exist. The objective of this practice is to evaluate the effect of temperature on the viscosity of water through molecular dynamics in GROMACS. Methodology. These are the stages of molecular dynamics and their implementation in MOVASTER. The first stage is minimization, that seeks to minimize the potential energy of the system in order to eliminate artifacts that may be problematic in the following stage. This is because potential energy is related to the force suffered by an atom. So, if the potential energy is very high between two atoms, this will generate an error in the simulation. The second stage is the heating of the system, in which kinetic energy is added to molecules of the system. So, in this stage, the temperature of the system increases. The third stage is the calibration, in which the molecules are allowed to move freely, so that the kinetic energy can be distributed among them. The fourth and last stage is the production, in which the molecules are allowed to move freely and the trajectory is obtained. This is the latest stage of the process and the most important, since the results are what allow the analysis to be carried out.
I'm gonna present you the results of the three stages and also the analysis of these results. In the first stage, we have the warming stage that we have to remember that in this stage, we minimize the potential energy and we charge a molecule with kinetic energy in order to charge all the system. So we have three graphics. Those are kinetic energy versus time, potential energy versus time, and temperature versus time. Kinetic and potential energy are in unities of kilojoule per mole, and time is in picoseconds. Temperature is in Kelvin, and time is also in picoseconds. In the second stage, we have the production stage that makes reference when we let free the system and all the molecules began to move freely around the system. So we have the Coulomb versus time that makes reference of the interactions of Coulomb in time, the kinetic energy also, the potential energy, the total energy that makes reference to the sum of the potential and the kinetic energy. We have also the temperature versus time, and we have the interactions of van der Waals versus time. In the last stage, we have the equilibration stage that makes reference when the system became to an equilibrium, and we have three variables to analyze that are kinetic energy, potential energy, and temperature versus time. So we can saw three great aspects of the result that was that the relation between temperature and energy. So as long as temperature increases, the molecules are more excited and this promotes collision in consequence. The energy of the system becomes greater. So we can saw that in the first stage, that was the warming stage, we know that the energy, potential energy in specific, became so low. But as long as time passes, this began to increase. Also, with the kinetic energy, we know that a molecule was charged, so that is why it begins in a great level. But at the beginning, when the molecule is not collisioning with with some other molecules, it decrease. And when it start to interact with other molecules, it also again arise. So that is why we can see a relation direct with temperature and energy. As a second aspect, we could see the kinds of interactions. So we're not dealing with molecules charge or so charge. That is why Coulomb forces take a negative value. However, we know that van der Waals are always present. And in this case, when given that we are working with molecules with a total of 17,000 molecules, it it is consequent that the van der Waals interactions are greater than the Coulombs, because as long as there are more molecules, the van der Waals interactions become greater. And finally, we could see that the minimization of potential energy has an impact on the warming stage. So, as we know, at the beginning of the simulation, we have to minimize the potential energy to avoid repulsion between molecules. So, this can be seen in the warming stage. Why? We could see that at the beginning, the potential energy becomes so low, but as long as time passes, it increases. Also, two aspects to highlight is that in the potential energy, as I said before, we can see the stage warming is so important, and this could see in the three temperatures. And also, as long as temperature increases, it's more the potential energy that the system win. So, to end with the data analysis, we could see that in the equilibrium, there are no so many variations, because the system is beginning to make this equilibrium, so it becomes to have a tendency to kinetic movement all. So that is why it is intuitive that kinetic potential kinetic potential and temperatures begins to have a clear tendency, and there are not so many variation in this stage. So we can say that the system has reached an equilibrium, and that's all the stage of the simulation.
Hello, now we present the conclusion of the experiment. The first conclusion is that using GROMACS, it was possible to conclude that the viscosity decreases as the temperature increases. In other words, the objective of this practice or experiment we can check because we can present and show that the relationship of these two characters doesn't be linear. The second conclusion based on the conservation of energy. In other words, we can say that during this process, the kinetic energy can be transferred into potential energy, or the potential can be become to the kinetic energy. For the reason, we can conclude that this natural law will be checked in this experiment. Thanks.